the tangent function. Okay, so you can see that this one looks very different than the sine and the cosine waves do. And you also will notice there's a line outside of our circle. That's called our tangent line. Okay, so this line right here is our tangent line. It is tangent to the circle. That means it touches the circle at exactly one point right there, and that is the only point that it touches the circle. And so the tangent function is the distance to the point on the circle. So let's just talk about this definition over here for a minute. Cosine and sine of an angle derives from the coordinate of a point on the circle. Right? A point on the circle. So when we were talking about sines and cosines, we were always talking about this point on the circle. Okay? But a tangent of an angle derives from the coordinate of a point on a line tangent to the circle. Point on a line tangent to the circle. So one's to the point on the circle, and these are to the points that are on the tangent line. So the distance from the center of the circle to the point on the tangent line. Very, very different, okay? So you can see that these distances obviously make different lengths away from the actual line of the y-axis. So they correspond with how far away they get and how far away they get in the negative direction, okay? Now, the graph approaches, both of these like wavy lines go north and south, and they approach what we call vertical asymptotes. So they get closer and closer and closer and closer to those two lines that never really actually touch them. This particular function never actually becomes fully vertical. Okay, it's just approaching verticalness, but never really gets to that point where it's vertical. So let's find some tangent values on a graph. So we have a graph, and we're going to actually just kind of read the graph a little bit, is what it's telling us to do. So we're going to use this graph, this one right here. Y equals the tangent of theta. This is the parent graph. And I want us to find the value when the tangent is negative pi over 4. So you'll notice negative pi over 4 isn't on the actual x-axis, but this is negative pi over 2, and this is 0. So what would 1/2 of that be? 1/2 of negative pi over 2. Multiply across the top, negative pi, multiply across the bottom, 4. So half of negative pi over 2 is negative pi over 4. So this is negative pi over 4. So that means that this is positive pi over 4. And so at negative pi over 4, we want to know what's the graph. Where is it? So negative pi over 4 is at negative 1. Tangent of 0 is 0. Pi over 4. So now we're on the positive side. So we're at positive 1. Pi over 8. So again, now I need to figure out where pi over 8 is. So look, 2 times 2 is 4. 4 times 2 is probably 8. Yes? So we have pi over 8. Whoops, right here. Half of pi over 4. So from 0 to pi over 4, half of that is going to be where we find the pi over 8. So this is pi over 8, and this is negative pi over 8. So we're asking for positive pi over 8. What is that value right there? So we make sort of a guess. It seems to be about halfway between 0 and 1, so I'm going to call it 1/2. Okay, so we just read the graph, find the point, and go up or down until you hit the tangent function, and then decide what the rise or how far up or how far down it is. Okay, now we're going to talk about the properties of the tangent, and then we're going to go ahead and try to practice graphing with you. So again, the function looks very similar to that of a sine or a cosine, but these are different. Pi over b is equal to the period of the function, not 2 pi over b, just pi over b for a tangent, so that's different. And then one cycle occurs between negative pi over 2b and pi over 2b. So between those two is where the one cycle occurs. I should write between here. Okay. And then there are vertical asymptotes at each end of the cycle. Asymptotes at each end of the cycle. Okay. So there are our properties of functions. Now we're just going to practice graphing a few. Go to the next page. Graphing the tangent function. So let's just look at this example one first. So again, we find A in front of the tangent and B is right in front of the theta. So the period is going to be, remember, pi over B. And so we go this, pi equals pi over B, right? And then we need to cross multiply. Okay? So bottom to top and top to bottom, pi equals pi times b, and then to get b by itself, we divide by pi. Anything divided by itself is 1. So b is 1. The period is 1. Okay? So the period is 1. That means that we are going to have a distance of 1 unit wide. Okay? So 1 unit wide means it's going to be half a unit to one side and a half a unit to the other. Okay? So 1 unit wide. So if this is 1 unit, I need a half here and a half here. So this is where my first set of asymptotes are going to come in. Okay? Find the asymptotes. So basically, if it's 1 unit wide, it's 1 half in one direction, 1 half in the other direction. So that's what we just did. Plot 3 points in the cycle. So you can decide what you want those 3 points to look like. You just kind of be real careful about the fact that these are all going to be we're going to do one right here in the center, and then remember it's approaching this line up here. So maybe I'll put one here, and I'll match one down here. And so we're going to approach the line but not touch it, and then we make that little slinky curve, and then we approach the other line and we don't touch it. So we end up with that kind of looking function. Okay? And we do that at least a couple of times. Usually there's a couple of these. So remember, we want all of these sections to be 1 unit wide. So this is a half, and a half, and a half, and a half, and a half, right? So 1 unit wide, the first one, and then 1 unit wide, and then 1 unit wide, and we would keep going. So that's how you're drawing those. So we'll just do another one right here, right? And then we'll just do another one right here. Okay? Let's try a couple of examples. And then see how we... Okay. So here are 2 graphs. The first one is going to be y equals tangent theta. So A is 1, the period is 1, and that is pi over b. And if we cross multiply, bottom, bottom to top, we get b equals pi. So that means that it is pi units wide. So I'm going to go half a pi in one direction, half a pi in the other, right? So I want one full pi. So this is a half a pi, because it's 0 is pi over 2. You can probably see yours a little better. This is pi over 2, pi. This is negative pi over 2, negative pi. So if I want a pi unit, I have to go half a pi in one direction, half a pi in the other. So this is one full pi. You with me there? So that's where my asymptotes need to go. One full pi unit, and then you just kind of keep going. 2 boxes each, because we know those are all half pi boxes. Okay, and then the amplitude is negative pi over 2b. Okay, negative pi over 2b. So we're going to go ahead and put our graph in here. So there's our 0. We're going to approach and approach. So we're going to do this. Right? And we do that a couple of times. So I'm just kind of making sure it crosses the x-axis in the middle of each of those periods, right? And then I just kind of draw a line up there close to the line and down the same distance across the line, because they're symmetrical, right? It's the same above and below. So I try to make them look as similar as I possibly can. Right? So it's important too that when you're doing them, you try to be as accurate as possible with the amplitude. So let's really try to focus on this one. And the last one I was really just focusing on getting those asymptotes in the right place. Now let's take it another step with this one and see if we can really nail down the amplitude. Okay? So we have A is 1. So amplitude is 1. Right? And then we have 2 equals, so this is the period, right? The number in front is always the period. And that is equal to pi over b in a tangent. Room cross multiply top to bottom, bottom to top. 2b equals pi, divide by 2. So b equals pi over 2. So a half a pi. My distance left to right has to be a half a pi total. So this is a half a pi, this whole distance. So I only need half of that, because remember, from 0, I have to go left and right that distance. So I need a whole box is a half a pi, then I'm going to go half a pi, so quarter pi on this side, quarter pi on this side. And that makes a full half pi. Quarter in one direction, quarter in the other direction. Half pi. Right? And I know that the full, this from 0 to pi over 2 right here. So I know that half a pi is one full box. So I take a half a box on this side and a half on this side, and that makes me my one full box. So I'm just going to keep doing that for all my other asymptotes. Okay. Okay, so far we did really good with that part. And then in the last example we just did, it just kind of drew the blue lines in there. We have to pay a little bit more attention to what we're doing with that section, which is to say that your amplitude is always negative pi over 2b, okay? Negative pi over 2b and positive pi over 2b. We can just figure 1. Negative pi over 2b equals my amplitude, so equals 1, right? So then what I'm going to do is I'm going to take my pi over 2 that I just figured out, my pi over 2 units wide, and I have to plug that in. So I get negative pi over 2 times pi over 2. So I get negative pi over pi, or negative 1. So that means that the distance up and down is going to be plus 1 and negative 1. These are your y values. So plus 1 and negative 1. So that means I'm going to start here, and I have to go positive 1 and negative 1. So the closer that the turns are, the more squished down the actual function is, and the further away they are, the straighter they are. You can notice the one on the left, they look a little more straight, and the one on the right, they look a little more squished down, right? So here I'm going to go up one, across the middle, down one. Okay? Here I'm going to go up one, across the middle,